The next congruency axiom is ASA congruency rule. As I told you before, this A in this ASA stands for angle and this S stands for side. Means that angle side angle congruency rule. So, previously in SAS we have seen what? Two sides will be equal. In the middle there will be one angle. Look at here then. Two sides will be equal. In the middle there will be one angle that will be equal. Now, as like that, here when they say ASA means what? Two angles should be equal. A side which is common for this both angle, the common arm for this both angle is equal. Common arm means that side should be equal. So then we can say it is ASA congruency rule or axiom. So, for example, two triangles A, B, C, B, Q are always no X, Y, Z and N, O, P. No. In these two triangles, is a X is equal to P and Z is equal to O and this XZ is equal to PO. Then, by this ASA congruency rule, see, one angle, the another angle, the side which is common for both the angle which are equal to the other triangle are equal. So, by ASA congruency rule, we may write that the triangle X, Y, Z is congruent to the triangle. The side XZ is equal to what? PO. In particular, X is equal to P and Z is equal to O. Okay. That manner we have tried. See, XZ will be equal to PO. Also, X is equal to P, Z is equal to O. So, this is what this ASA congruency rule is about. Now, what if we have the side which is not a common arm, a non-common arm is equal? Then what we can say? Same name I am taking, else PQ simply. X is equal to Q and Z is equal to P. And the side Y is equal to QR. Then the rule name is slightly different. In this we said ASA congruency rule. So here angle, side. AAS congruency rule. What congruency rule? What is difference from that and that? This is in ASA the common arm will be equal. In this the common arm, not the common arm, but the other side which is not a common arm is equal. Okay. So in this, how you will say the triangle XYZ is congruent to triangle X is equal to Q and Z is equal to P, QRP, and shall we say XY is equal to QR? Yes. Okay. Now we will talk about an example in the same manner. Instead of that side, see, X, Y, Z. Here one, here two angles, here one. Here two angles, here one. This side. P, Q, R. Shall we say that side? Shall we say these two triangles are congruent? The same thing, as per this angle, we may write triangle XYZ is congruent to triangle QRP. See, X is equal to Q and Z is equal to P. The relationship that XY is equal to PR can be preserved here or not? Think well and answer well. XY is equal to PR. Shall we say XY is here, PR is here? We can't say. Then shall we rearrange this like what? RPQ. Then XY is equal to RP and our X is equal to, PRQ itself will write, right? Think well. XY became RP, girl. Then if we write like this X will not be equal to Q. So, shall we say these two triangles are congruent in this case? No. Or else, if there is any other way, you try and let me know. You try all the combinations and let me know. Make it fast. Do it now. In any way, it will not be equal. Either this X and Q is collapsed or else this XY and RP things is collapsed. But these two do looks like same, right? So, why I am giving this example means you should not be confused with this. You should know when this AAA should be applied, when this should not be applied. Okay? And that is it. You understood the difference between AAS and ASA, right? Okay. Only these are there, like SAS, AAS, ASA. Don't think that A stands for angle, S stands for side. We can mingle everything, whatever the combination. Like SSA, Sarva Shiksha Abhiyan, that type of congruency rule and all not there. Only these three are available so far we have seen. After this, another two we may say. Okay. Apart from this prescribed congruency, there will be no other congruency are there. Okay. So don't take it for granted. We may shuffle S and A's, we'll get the congruency like don't think. Okay. Then shall we see an example in this? Shall we?